other what you know about MongoDB. We'll absolutely inject expertise from the likes of Brian, who's flown all the way from San Francisco
This evening.
yeah, to fly all around Europe and teach everybody about MongoDB. Brian is one of our most tenured engineers. He worked in the engineering team regionally, then in consulting, and he now works for developer advocacy. So, any questions, come and ask me. You have my meetup address. We love you to give us feedback on what you liked from the event, what you'd like to see in future events. If anybody here would like to do a talk at a future event, you can contact me directly via the meetup group, or come and get my card and I will help get that sorted out. I'm going to hand over to Brian because he's got lots to talk about, and we'll see you all at the break. If you haven't registered, can you just let me know at the break who you are? Because we want to track who actually turned up, because that's how I get measured, who actually comes to these events as opposed to who registers them. So if you just come and grab me at the laptop and just say my name is, and I'll tag you off. And there will be special emails for people that turned up. Okay, Brian, take it away.
Thank you. Thank you so much for coming out. I wasn't sure that everybody would be sufficiently recovered from last night. So I think you guys are a brave crowd. Personally, I'm still recovering myself, but I think we'll still have fun. My name is Brian Renaro. I'm a developer advocate. As Joe mentioned, I've been with MongoDB for 4 years, just over 4 years, which started out, we were less than 100 people at that time. And I did a check about my employee number, and I was employee 99. Later, I did another check, and I don't think I was accurate on that number, but I'm sticking to it because it's a better story. So anyways, one of the things that I wanted to talk about, there's a couple of special things that I wanted to talk about tonight. I'm so appreciative of you guys coming out. I'm going to do a little bit of a pivot because I wanted to do some special things and talk about some special patterns of MongoDB. We'll definitely cover some 3.2 stuff, and if you have questions about how to use MongoDB and all that kind of stuff, or you want to find out more advanced stuff, then happy to answer those questions. Just a quick show of hands, how many people are brand spanking new to MongoDB? Okay, cool, that's wonderful. How many people have used it in some way, played with it? Okay, that's great too, that's fantastic. And how many are like, have something in production, that's great. Some people with their hand up for all three, so that's cool.
Brian, can I ask you,
Yep.
how many people here are paying for MongoDB? Awesome!
Oh, whoops.
Compare the market, you're our heroes.
Okay, so tonight we're going to talk about some IoT things. What I like to talk about when we're discussing technology is to put it into context, like relevant context. What I find is that I can rattle off a litany of different features, but I like to put things with examples so that you can see, even if it's not the same vertical or industry that you're working in, once you understand how it works, you can start thinking about how it might apply to the way that you're coding the industry that you work in. So we're going to talk about architecting the Internet of Things, or IoT. So to start off, I want to do just a little bit of a quiz. Can anybody tell me what this is? If this comes out okay. Can anybody take a guess at what this is? The gentleman in the back. It's a semaphore tower. That's exactly right. You guys are much smarter than the North American audiences. This flummoxes people. This is a semaphore tower. Who can tell me where it is? France. Okay, so the semaphore tower, actually the term semaphore was coined by the inventor of this system, Claude Chappe, it was his name. And what happened here is that this was a series of deployed network nodes, the first wireless, practical, codified wireless network in the world, and they were dotted around France. Okay? It was an optical telegraph. And what happened is that you could reposition these hands to communicate, just like in naval semaphore flags, to communicate messages from point to point. And these nodes were distributed about 20 miles between each. And the operators inside were a special breed of person. They had in their uniform, they had little brass buttons. Unscribed was ever vigilant in Latin, I believe, because you had to sit there. If somebody's trying to flag and say, "Hey, I've got a message," you had to be looking at the next station to make sure you didn't miss the message. Now, as you can imagine, the baud rate on these things is abysmal, right? Because you got to reposition the arms and everything like that. So what's fascinating about this, what I find fascinating, are old solutions to modern problems. And because the baud rate is terrible, how do you deal with bandwidth restrictions?
Double up.
Compression, exactly. So they developed a compression algorithm, very, very similar to the compression algorithms that we use today. Instead of saying, "Hey, Jock, take a look at me, I'm about to start the message," they would just use gestures that signified message begins, message ends, and then compressed on other frequently used words. This worked so remarkably well, it was only replaced until, its data service was only replaced by the electrical telegraph in 1856, right? This was invented or put into service in 1792. And in that year, they could send a message 100 kilometers in less than an hour. In the 18th century, which to me is amazing, right? It was changing, game-changing. I'm told that they actually could get across France from Calais to Caen in less than 15 minutes when it got really, really efficient. The inventor was, as I said, a gentleman named Claude Chappe. He was an interesting person. His brother went on to fight the electric telegraph that was replacing his system, saying it was less reliable because somebody could just come along and snip the wire. How could you substantiate a network based on wires? But there's a fundamental flaw with Mr. Chappe's system. Can anybody guess?
Weather.
Weather. And what hours of operation do you think they had? So we'll say that forever engineers have been dealing with network partitions, right? And flaky networks. Interestingly enough, I said his brother was the one that was fighting the ingress of the wired telegraph. Claude Chappe didn't make it to 1856. In 1805, it sounds morbid, in 1805 he threw himself down the well of a Parisian hotel. I don't really know why, I just would say that engineers never seem to make money on these systems. So that was, okay, never mind. Morbid joke. Anyways. Okay, so let's jump in. Now, when we're talking about the IoT, there's a lot of, how many people have heard that term? IoT, yeah, it's pretty buzzy, right? What I find is that it's a term that's been around for a little while, and it's jumped up in popularity lately, right? Really non-linear, like a lot of people are talking about it. In my experience, the way that I've worked with companies, we've done a couple of IoT projects in different types. Some would classify IoT as mobile devices of some sort. There would be embedded systems in vehicles or other such stuff. I've been working quite a lot with power companies in the United States that use smart meters. And in this case, the smart meter has a network card inside of it, and there used to be a guy or person that would come along and read the meter reader guy, and record how much energy you had used in the reporting period. Now on these systems, there's a truck that drives through the neighborhood, and as it passes your house, it picks up the reading there without stopping. Interestingly enough, some of the things that we were doing with this kind of an IoT space is there is the natural need to ingest the data and read the meters to get billing information, but there's a lot of processing that's also tied into IoT, because you collect these raw logs and you need to put some kind of learning and understanding on these logs. In this case, they're looking for failures on the system. In one case, the big metric that they were looking for is that if the meter goes over a certain temperature, failure is imminent, right? It was the weirdest thing. I would have assumed that if there had been variance in the current or variance in the voltage, that would indicate that there's some kind of problem with the meter, but it was actually temperature was their main thing to monitor. If several meters are showing these kinds of error conditions, it indicates that maybe something upstream in the network is about to fail like a transformer. So they wanted to do a lot of processing on the system to see if there was going to be a grid failure. There's also other stuff I learned that people are forever trying to be fraudulent with meters. Like, they know that there's a truck with a Wi-Fi card that's running by through the system, so they'll try and wrap the meters in tinfoil so they can't be read. They'll actually take the meter out and turn it upside down with the hopes that it reads backwards. And most ingenious is that they'll take meters off of derelict houses and replace their own with that meter, so that somebody else or some other place gets the bill for their electricity. It's all sorts of fun and games. Of course, IoT also includes. I think this is kind of a funky slide. There's IoT includes devices which record things about ourselves, right? Fitbit is kind of like, that's not cutting edge technology anyway, but there's an idea that it's sending data about who you are, what you're doing as a person. And what I see in the next few years is I think there's going to be an explosion of embedded devices in ourselves. Hopefully not exploding while they're embedded inside of us. But the idea here is that I think the medical industry is going to have a great amount of growth with the kinds of things that are monitoring internally to us. And I think that's actually pretty exciting. That stuff is already happening. So that includes IoT. Okay, so let's talk about strategies for dealing with IoT. Well, as you probably would guess, is that we need to deal with a lot of different, we need to deal with just the raw ingest of this data. There's going to be a lot of data, it's going to be coming in. Sometimes these systems, they'll get isolated. If they're distributed devices, they can't report in their metrics, their logs, until they get connectivity, and then suddenly there's a burst of this information coming into the system. So in addition to just a raw stream of data coming into the back-end servers, including the database, there's also going to be burst periods as well. So we need to handle that. And a lot of IoT stuff is going to be temporally based. It's going to be time series data. Now, how many people have heard about event sourcing? I'm really curious if this is a term that's been, okay, a couple people, right? Okay, good. It's an interesting term. It's something I find kind of deceptively simple, but deceptively, it seems, when you learn about it, it's going to be obvious how it works. But it's a kind of a buzzy term that I'm kind of fascinated with. And I think event sourcing is a kind of data processing that's going to be very important, is very important to IoT and other industries. So what is event sourcing? Okay, the best way to get into it is to say, this is the other subtitle I found, is the best ubiquitous pattern you've never heard of, right? Some of you who are ahead of the curve, of course, you get a gold star. But I find that a lot of people are not familiar with this. But it's a great pattern. Let's say I'm going to do a banking app, right? Which I think is probably popular with you kids these days. I'm going to do a banking app, right? And if I just said, like, this is programming 101 with integration to the database 101. In order to do a banking app, I need to persist state about my accounts in this banking app. And so I'm going to have user A and user B. These are actually patterned off of real people that happen to have a name called user A and user B. And these are accounts. Each record is an account, and inside of this account we have $427 for user A and $550 for user B. Now, if I want to do a transaction between these two people, what do I do? Well, I'm going to say that user A is going to buy, oops, my slides are a little bit slow. User A is going to buy something from user B that costs $5. Okay, so the pretty simple idea. I'm going to decrement $5 from user A and then credit to user B. What is required here? Transaction, right? We're dealing with a financial transaction, but now we're into the realm of what we would call a database transaction. And then of course, typical methodology, ideology, however you want to call it, database design would say, like, okay, in order to do this kind of change from user A to user B, I need to do this operation, I need to update 2 records atomically, right? Because I don't want to fail in the middle of taking $5 out of one account without confirming that it's also pushed into account number, the second account. Except for the problem is, nobody does it this way. Nobody does it this way in mature financial systems. What they do instead, well, the problem here is, whoops, let me go back just a second. Whoops, stop.
I blame a Windows laptop.
You see, I couldn't do a rollback on the transaction. You see the problem there? What's the problem with this? What am I storing here? I'm storing state, current state, right? The application state is stored to the database. What if that state's corrupted? let's say that there's a logical corruption, that I do a new release of the application layer and it corrupts the state of the database. What do I do? What would you do? How do you solve a problem when you have to get back to a prior known good state? Rollback? How is a rollback accomplished? Checkpointing, that's a good part. What if I wanted to find out what happened? How did I get into this state, right? Before you even go to a rollback, we're going to return the database to a prior state. You can back up, but you need to know whether it's all right to back up if you really are corrupt. You need to find out how you got into this state. So where do you look to see what happened? Log, transaction logs, or just logs, anyways too, right? Love your logs, right? The problem with a system like this is that if I'm only storing my current state, I've lost my ability to determine how I got into that state. If it becomes corrupted, the only opportunity, the only choice I have is to go back in time to the last known good state, and I will have lost everything that happened after that last good state, right? I may lose valid transactions because I don't have anything but a prior snapshot or checkpoint. So event sourcing says you're doing it wrong, right? Just like my slides. Let's go. Wake up. Okay. Did I go back too far? There we go. Event sourcing says don't think about application state. We're not going to persist it in the database. We're going to be dealing with application state, but we're not necessarily going to store it as an entity in the database. What we are going to do instead is something very, very simple. We're going to, instead storing state, we're going to store deltas to the state. We're storing the event log, the transaction log, okay, in the database. What's the purpose of this? The idea here is I'm going to read you a story now. Like I'm going to sit down in the chair and tell a story. Well, kids, let's learn about database programming. The idea here is that I can play back the log and determine what my state is by replaying the events, right? I start at the beginning and I play all the way down and I determine that at time sub 12, my state is 9. What is more than that is I can go back and replay a time in the past. I can tell you what the world looked like in a prior state, at almost any other state, right? In fact, the application state A, some people describe event sourcing as being the first derivative of the transaction log. I derive my application state from the transaction log, right? Or the event log. So one term I want to put in here is we've thought about domain objects. Has anybody heard that term, a domain object? Mm-hmm. Okay, yeah, domain objects are like the thing that you're dealing with. If I'm dealing with a product catalog, a domain object might be one product. If I'm dealing with a gaming platform, the domain object is the user account. But then there's domain events. Domain events are the things that change the state of the system. Like something happened, I record what that something is, and I can derive my domain objects by playing the domain events, right? So that's the main idea with event sourcing. Whoops, hang on, there we go. What if somebody attacks me? Is this a safer system? What if someone attacks me? The easiest way is someone starts putting false transactions into my system, right? They start making financial transactions that are wrong, right? Or they're trying to do like a very simple kind of attack on a website is to click attack, or try and exhaust my clicks or views. What do I do here? Well, that's okay. The attack I can deal with because I've recorded it in my event log. And I can always go back and replay my state, ignoring the attack that I've detected. I can reconcile my situation. Plus, I have a record of the attack so I can analyze it and protect myself from it in the future. If I really wanted to get crazy with it, I can analyze the attack and it becomes evidence in court in some fashion. Okay, so that's part of the thing that makes it robust. Whoops, fat fingers. So event sourcing was an idea that was characterized. The name came up with two engineers named Greg Young and Udi Dahan. And actually it also uses a system, they both kind of work together to characterize the system. Event sourcing uses something that's called command query responsibility segregation. Say it 10 times fast and you'll impress your friends at parties. You might as well laugh, the jokes don't get any better. So everybody shortens that down to CQRS. Yeah, exactly. And so when you say like, well, you should really be using CQRS, people would go like, oh yeah, I should. What's CQRS? Yeah, so I'm going to tell you. Anyway, so event sourcing and CQRS are pioneered by these gentlemen. But they will be the first to tell you that they didn't invent this. This goes far back. How far back do you think this goes, this idea? Probably the dawn of human writing, actually, quite frankly. Because the idea here is, yeah, I'm serious. Oops, somebody's paging me. Not now, Mom. Does anybody want pizza? So, okay, so why do we say this? Because this is the way that financial systems work. You can go far, far back with this idea because it's a robust system for recording events on a system. This is the Re Augusti Divi Augusti. It's Latin. I don't pretend to know Latin, although I just did.
I'm Belgian, so I know.
It's the Divine Deeds of Augustus. And this is a little bit of Roman propaganda, but what it also includes is a discussion of part of what made Augustus so powerful is he did his own accounting, right? That's how he got in charge, right? And one of the things that are recorded here is his accounts, paying out pensions to legionnaires, retired legionnaires. And what he's recording is not the current state, he's recording the transactions or the payments that he made, so you can always recalculate where he is and what his spend was. And as far as database durability, that's pretty robust right there. That's cold storage. Yuck, yuck, yuck. Okay, for people that I think it's hilarious, I don't know what's happening, you guys. So people who like to have their technology explained in more modern terms so they can impress their friends, you might have already guessed that this is the same kind of system that's used in code repositories, right? We save the log. Whoops, go back. It just went over. Man, I am fat fingering this all over. Hang on a second. I'm gonna go back here. And you could tell that the rhythm I had going was so great. Go back over here. Okay, there we go. There we go.
Would you like to transfer that to a real computer?
Nobody makes me stow this in the airplane because nobody thinks it's a real computer.
It isn't.
Yeah. Go. Okay, there we go. Let's go present. Ta-da. There we go. So the log that we're changing the log of the changes to the code repository. And we can regenerate different snapshots from this log, right? Same idea. This is why I say it's a ubiquitous pattern. In fact, Bitcoin uses this exact same thing. What is the blockchain? How many people have heard about blockchain? Yeah, there you go. All the kids are into it these days. They get together, they play records backwards, and they discuss the blockchain and cryptocurrency. So the blockchain is a distributed ledger that contains what? The last 5 transactions, the last 10, it contains the entirety of all the transactions that have occurred within the system. That's event sourcing. And if it's good enough for blockchain. Okay, so, and another thing you might already derive too is actually when I discuss about event sourcing, some people think about it, I've heard about it in databases. I didn't understand that that would be something that would be used at the application level. If you pull open a relational database, it uses event sourcing underneath the covers because it has the transaction log, right? So the MongoDB is similar, the same idea here, is that we have a log of deltas that we have called the op log. And the primary is where all the writes come in, right? All the writes to the system come into the primary. It records it to its off log. The secondary tails that off log and applies those changes that the primary did to itself to keep itself in replication. Again, event sourcing, right? Pretty cool stuff. Any problems with this? So we have a pretty good grip on what event sourcing is. Any detections of what problems are? Yeah.
I actually implemented this for one of our systems recently, and one of the biggest issues is the efficiency of querying concurrency.
Ah, this is so perfect. I love that when that happens. That's exactly what this, hopefully, slide, or I could just compress it again. Yes, if my only current state, the only way to get my current state is a very reliable replay the entire log, what's the problem with that? performance. I'm going to have to go back. Maybe my log is 3 years old, 3 years of data, 4 years, 5 years. How many terabytes is it? If every time I'm querying to get my application state, I have to replay the log, it's not going to work, right? It's not going to be efficient. It'll work. I'll just have to wait for it. So what's the solution? The solution is to create snapshots at given intervals. So if I want to go back to this state right here, I go back to that snapshot, the preceding snapshot just before the state I'm after, and then replay the log up to the target state, right? So I have a set of snapshots that I go from. What happens if my snapshots are wrong? No problem. I regenerate the snapshots because I always kept the log. The important thing to remember is that you keep the log, and the log is immutable. You never change it. Actually, I was talking to our finance people, and all of a sudden I was getting really nerdy with them about how finance laws. We know that there's immutable documents or immutable records to a database. You can't change the log. If you change the log, you've changed the history of how you got there, and it can lead to all sorts of mayhem. Finance is the same way. You're not allowed to cook the books unless you're a power company based in Texas in the early 1999, and that's not going to save you either, right? So you can't cook the books, right? You keep this immutable log there, and you can always regenerate. If you find that the way that your snapshots were generated were correct, but you want to improve them with extra data that you can derive off of the log, it's okay. You can regenerate the snapshot.
I'm just thinking about my bank statement. Each transaction's like that, like how much I spent or somebody put in, but it also tells you the balance against each entry.
Right.
Why can't you just write the state in the log at every entry?
You could, but the problem is that, well, that's actually like, that would be like a Lambda architecture, right? Where you have the current state. I'm using all the buzz terms I can right now.
That's okay, I am impressed.
Yeah, so that's true. That's the next step with this, is like, well, wait a second. Even if I go back to the last snapshot and replay forward, every time I come into the system, I want to get current state, I go to the snapshot, play up. Why do I need to keep doing that? Maybe I should keep, in my application state, a live stream that comes through on the application server that also is feeding the backend database, right? I'm going to split the stream, one to a backend system and one to the live component, or the streaming component, right? The real-time component, like a Lambda character in Greek. And I'm going to keep updating the real-time component. If it fails, if it becomes corrupt, what do? Regenerate. That's right, off of the log. If I turn on new servers, they initialize themselves by replaying the log and coming up to that state. So that answers that question. But you always can change. If you found that you made a mistake in the way that you calculated your running balance, that's okay. You can always remediate. Now, in this slide too, we don't only have to have one view of what the log is telling us. We can generate different snapshots. We can generate different snapshots or points in times or views on the data, right? Because the log, we just replay it in different ways. We do different projections on them to come up with different views of the world. So maybe we're trying a new model, a new stochastic model that we want for a bidding system or some other kind of thing. We go back, we try out this new model. We can always regenerate different models and eventually maybe replace them with a better one. Run tests against it, whatever. Go back and revise. If we learn something new about our users, some kind of like demographic piece of information, I can apply that new piece of information back to the prior logs and find out how many of those users I would have seen in the past if I'm discovering new audience. In online marketing, we were always trying to look for new audience. Like, who are the users that you didn't know you had, or customers that you didn't know you had? Friend discovery and stuff. So how does this relate in IoT? Well, in this case, we can use event sourcing in the same way, because there's a lot of similarities to financial systems as there would be to IoT in this case. This is actually, does anybody know where this is?
San Francisco.
It's San Francisco, but there's a specific street here.
Crooked
Street. This is Lombard Street.
Lombard Street,
okay? And they're coming down the street, and there's lots of tour buses. I used to live right about here, very close to your lab. And at the base of the street was my apartment, or flat. And so, and there would be tour buses that would go by every 10 minutes, and they would crack the same, much like myself, you crack the same corny jokes day after day, 10 minutes after 10-minute period. Lombard Street, ladies and gentlemen, Lombard Street, the crookedest street in the world. Some people say as crooked as Wall Street. Ha 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 ha. 10 minutes later, Lombard Street, ladies and gentlemen, Lombard Street, the crookedest street in the world. Some people say is crooked as Wall Street. So when you go there, you can say, is that Lombard Street? Is that as crooked as Wall Street? If you're not there. Anyways, so what we're going to do here, there's actually a lot of data sets that are out there that I like playing with. One of these data sets is, it's updated on a monthly basis. It's the prior month's records of the GPS location on a minute-by-minute basis of every cab in San Francisco. And if you've ever tried to hail a cab in San Francisco, there's about a data set of about 5. You have to live there to appreciate how awful there's no cabs in there. But yeah, there's lots of cabs. See, the jokes are pretty stale. Even when I'm thinking of them off the top of my head. So anyways, the notion here is that it's sending back GPS location. In fact, this is what one of the logs would look like. And you can see it's in JSON format, import it into MongoDB. And basically the idea is I've got my primary key field, the underscore ID. I have a timestamp that says when this record came in to the system, the cab code for the car that's being driven around, where it actually is in the city, and whether or not it has a fare. Meaning that if it's 0, there's nobody in, it's not earning money, it's just roaming looking for a fare. If the flag is set to 1, then we've got somebody in the cab. Okay, so that's my domain event, right? This tells me where an individual cab is at a certain period of time in the city. I can aggregate over this data and collect this. I can replay the log, and whenever the flag goes up, I know that a fare has started. And I've gone into fare state, and I start collecting those logs. When the flag goes down, the fare is over. The person left the car. Now I have a record of that cab, where it went, and this is what it looks like. This is what it looks like. Wow. This is what it looks like. Here, right? This is one of the records. Now, this, after I ingested this data and performed that operation, I pulled in the data like this. This is actually kind of funny because this is my old neighborhood. This is a different neighborhood I lived in San Francisco. What do you notice about this cab ride?
It's as the crow flies.
Parts of it are as the crow flies. It goes through city blocks, which is actually kind of accurate the way the cabbies drive in San Francisco. But one of the blocks it goes through, coincidentally, is my old apartment right there. It's going right through my bedroom. So I thought that was pretty funny. But this would be one of the records that the flag started here, he starts driving, and then it comes over here, and that's the end of the trip. So one thing about saying that log and being able to revise our views on what happened in the log, there'll be network dropouts. But one of the views that we can change is we know how to interpret that this guy must have made the corner here, right? Even if there's missing parts of the log, we can still derive a view that's accurate of the world. And we can get better about it. Like we might get higher accuracy off of what was going on in the system. This is what that view looks like. This is the aggregated part. I have the same cab. This is the start date. This is the end date of the ride. And these are the points that occurred in that cab ride. There's actually more, but I think I truncated it out here for sake of putting it on the slide. Pretty cool stuff. This is the same cabs for the entire month, which I thought was pretty cool in San Francisco. I've seen other people interpret this data set where they do real-time animations. That's really kind of cool. You see where the cabs are driving and stuff like that. That's really cool. I like the fact that he made it to Oakland Airport. There's a big, thick blue line for going down to SFO, so this guy's making a lot of money on airport rides. Maybe I was on that cab. Okay, so the main idea here is that typically we're going to be thinking in terms for event sourcing of domain events and domain objects. For those of you who have not fallen asleep, when we talk about domain objects, what are we talking about? We could be talking, in this case, the domain object that we're talking about is the fare, is the ride, right? That we derived from a series of domain events, the log, the event log. Cool? Okay, so let's think about that for a second. Can anybody tell me who this gentleman is? This is the most important Renaissance figure you've never heard of. This is Luca Pacioli. He was a good friend of Leonardo da Vinci, probably an educator of Leonardo da Vinci, in my opinion. Probably taught him math. So who is Luca Pacioli? He was a monk, and he was the first to canonize or to write down what we would call dual entry accounting systems, which is basically accounting 101. The innovation of doing this dual accounting entry system was that it allowed people to create a balance sheet. This was the first time that it appears in the West, this concept. This was 1492, I think, which was great because that was just in time for the age of exploration. And this innovation that he made on finance pretty much bankrolled the age of exploration. So what is dual entry accounting? The idea here is that we have accounts payable and accounts receivable, money in and money out. And we put that into our journal. The etymology of journal is it's the log, it's the daily log, jour, right? And then we aggregate the journal into a ledger. The same pattern that we saw with the cab ride, the points where the cab was, the domain events are aggregated into a domain object. That's the ledger. The ledger, the etymology of that is to lay, which I thought was pretty cool. The idea here is that the way that we're writing to the system is different than what we're reading from the system. Objects that we're writing to the system are different than the objects that we are reading from the system. The cab, the taxi example is a perfect example of that. What I'm writing to the database is an event log. What I'm reading from the database is the rides. That's what I'm interested in seeing, that I derive from there. Those things are different actions. So we have command, query, responsibility, segregation. In this idea, a command is something that alters the state of the system, or the state of the database, by writing one of these immutable logs. I've changed the state of the database. The query part is just a read off of the database, where I get data back, but I haven't altered the state, right? And so because my commands are different than my queries, there's no reason to kind of bundle them in the kind of CRUD fashion that we understand today in application systems. The responsibility is segregated. What does that look like? Well, that's CQRS. This is what it looks like on the page. And what it looks like in the system is, this is probably typically how we're taught to interface with a back-end data store, CRUD operations. Create, read, update, and delete, right? And the CRUD operation is usually done through one class, right? Well, I'm a Java guy, so you would have beans, or you would have getters and setters in a class that interface with the database. The same piece of code is doing both the reads and the updates and the commands and the queries to the database. The command query responsibility segregation says, if these things are fundamentally different, let's change them. Let's break out the responsibility into two separate components, two separate pieces of code, right? Well, immediately, what's the advantage of this? If I change the way I write, it doesn't affect the way I read, right? These are separate components, and now we're starting to delve into another buzz term. Where do you think I'm going with this?
Single responsibility.
Well, single responsibility, that's very good. Give me more accessible buzz terms.
Flux or pre-computed views.
Let's say something very, very small. I have a service that's tiny.
Microservices.
Microservices. There we go. Bingo. We'll just keep going through buzz terms until we're ready. Yeah. So the idea here is that we've changed the responsibility of these individual units of the application. So I feel a lot better about changing one component without altering the system, right? For all the maintenance that's in ease of maintenance and development that comes with. Another aspect of this is that I can asymmetrically scale these systems. So imagine that I'm doing lots of different ways of looking at the same event stream, the same event log. I interpret it in lots of different ways. Then I have an asymmetrically high read load in relation to my write load. So I can scale out my readers asymmetrically to match my writers. Okay, that's really cool. In fact, as I said before, I can derive, or I can create different versions of looking at the same event stream, so I can create different readers. This, as a microservice, reads the data one way, this next one does another way, another way, another way, another way. Let me ask a question. Everybody's heard microservices, right? Can you tell me a hard and fast rule about scoping a microservice? How big should a microservice be? How small should it be? Yeah, nobody knows. You're not alone, you're in good company. But I'd say this is one of the first clear definitions. When somebody says a microservice, this is a way of defining what you're doing. Single responsibility. Well, she's gone. Single responsibility. You're doing great. Single responsibility. Yeah, so this is actually really flexible. Now we're seeing that the way that we're dealing with our data, when we start thinking about changes in events, has an impact. It's kind of like an architecture pattern. We're getting there. It has an impact on the way that we deploy our system. In fact, one of the ways that Mr. Udi Dahan would say that because you have asymmetrical readers and writers, you can use systems like MongoDB to do asymmetrical reads and writes off of replicated secondaries. Okay? That's another idea here, is the asymmetrical pattern is also pushed on to the way that the data store is deployed. He's particularly bullish on document-made databases, MongoDB, because they're particularly good at presenting that kind of pre-aggregated, pre-joined view, right? Okay, so right about now you're thinking that this is the best thing since sliced bread. I'm going home right now. I'm going to do some CQRS my own, and have an event stream and event sourcing, and you know, heads of state will seek my counsel. Academics will ask me to lecture. People will, you know, children will cry with joy at your arrival. But I am an engineer, and I'm an engineer that's been using distributed systems for many, many years, so I have to be naturally skeptical, otherwise I will go schizophrenic, more than you see right now. So I'm always trying to think, where does it get tricky? Well, number one, with this kind of system, let's say that we've done this kind of pattern. We're asymmetrically sending, we have an asymmetrical load and we're taking advantage of reads to secondaries. What happens under these conditions, right? I lose one of those secondaries. I need to be really careful, because if I'm bringing this guy down for maintenance or something where he becomes isolated because of a network partition, where does the traffic go if it can't reach one of these secondaries? It goes to another, the remaining secondaries, right? 1977 was the, you know, I was 20 years old. Not really, although it looks like that. I actually met Caesar once. He was a great guy. No, anyways. The idea is in '77 there was this famous outage in New York that there was a set of relays that if the current peaked through the channel, through the power cables that came from Niagara to New York, if there was an overload, it would shunt off that current to the next line. The problem is this was during a peak consumption period. And so when one line surged, the shunt tripped and went over to the next line, putting double the load on that remaining wire. That one tripped and it was a cascading failure. That's the danger here. So while you can read from secondaries, you can configure MongoDB to do such a thing. The consulting engineer in me always says, be careful about that. Just be careful what you're doing and think about these kind of situations. Other places where it can be tricky is something called consistent replay. Imagine that my event log is recorded in dollars, but I don't only do business in dollars. There's I'm told, an outside world. I'm from California, so to me the outside world is 300 yards past I-5. It's funny to Californians. Not really. That's why they sent me here. So the idea is like if I can derive my state at 0.5 is $10, that's the current balance that I'm using. I want to use an exchange rate server to give me what that is translated over to euros. But the problem is that the rate doesn't stay the same. What if, and the tenet of event sourcing is that I can regain my application state simply by replaying the log. But if I replay the log, what's happened here?
It's used the current value of the exchange rate.
Exactly. I can't get the consistent replay. Excellent. So what's the answer to this?
Use an exchange rate service that offers the rate of every day in the past.
Yep. Or you record it right into that's part of the log that you replay. That's a good thing to do too. But a simpler idea is that you put it into the log as well. That would work. The only thing is that you need to make sure, damn sure, that your time syncing is correct. Like for instance, like having used distributed systems and having to go back against logs to find out what happened on different servers. Everybody, please put your logs always in GMT time, never in local. Please, like you're like, yeah, who would do that? You know, who would put their log in local time? Do it. Prove me wrong. Prove me obsolescent. That you will make sure that all your logs are written in GMT. I am obsolescent. Just prove it. Anyway, so we logged the state change. That became part of the deltas that we need to regain our state. Let me see if I put that slide in here. I didn't, but there's actually in Chris Evans' book, Domain-Driven Design. Has anybody read that? Shamey, shamey. No, it's a great book. But there's a notion there called a bounded context. The bounded context is the definition of everything, essentially everything where your model is consistent and encapsulated in what's called a unification. That means that you've got your shit together. It means that you've designed a system that there's no conditions that this model is invalid. And that's part of this idea here, is what is your bounded context? What information do you need to get your objects in a consistent state, a unification? So that's basically the idea there. I only really reference it, so I look smart. Okay, where does it get trickier still? Sometimes these systems, distributed systems, IoT systems, fail. This one actually, the camera bot kind of rammed into the skier, which that's a close-up. It's 3D, but I thought that was kind of an interesting problem. It smashed into the guy that it was trying to follow. Another thing that for medical records, you could lose connectivity for a varied amount of systems of embedded medical systems. So part of what we need to do here is that we're going to have to deal with failures, right? And we need, how do we know when something's wrong on the system? How many people were on pager duty? You guys are so blessed. Yeah, pager duty. Yeah, so pager duty is that you release, yeah, exactly. Oh, it's going off right now. Hey, Joe, can you take this? Yeah, you have a certain set of servers that you're maintaining, and you release it, and you release new versions of the code, and for the next 2 days you're sitting there, I can't party, I can't drink, I can't do anything because I'm waiting for the pager to go off in case there's a problem. There's an alerting system that's notifying me that there's something wrong with the system. So it's important to have a really good alerting system, especially when we're thinking in terms of many thousands of these distributed systems. This is another data set that I like. This is all the free Wi-Fi spots in New York City. So if you need connectivity in New York, just give me a call. I'll give you this map, and then you can go to the nearest Wi-Fi hotspot. But if we're maintaining this kind of an alerting system is very important for IoT systems, especially because the scale of what we're dealing with is pretty high. So we need an awesome, probably the best alerting system that we could come up with. And like with this one, the case is that we need an alerting system that is going to monitor when the temperature goes over that threshold. See, I got the slides wrong. I was thinking, where did I put the slide? So we need an awesome alerting system like the red Batman phone. Okay, I'll keep going. I'm going to wait until you get this joke because I feel that you can start throwing stuff now. Okay, so all is this to get to the point that systems have a notification threshold, right? When have I overspent, right? When has the temperature gone beyond the safe point? When have X number of my servers, the latency on the response of these servers gone over a certain threshold amount? I need to fire off an alert because either a system failure is imminent or I'm in a red zone. I need to take action. So what happens here in event sourcing systems is that I'm playing the log or I'm getting system updates. When I cross that threshold alert phase, I fire off a notification to a subscriber service, right? This is actually a pattern called system management services that I notify the subscriber starts the ticket, calls the pager, what have you, maybe takes some corrective action. But the problem is, what if I replay the log? How do I make the difference of what was the first time I got notified from if I replay the log, I start firing off all the events again and again and again every time I replay the log. This is actually, I'm really proud of myself on this one. This is a human analogy that explains this particular scenario. This is Saturday Night Live. It's an American comedy show. In this case, it's from 1977. There's Jim Belushi, if you know who that is. That's Dan Aykroyd. He was one of the Ghostbusters. In the back, that's a very young Bill Murray, right? Before Sofia Coppola movies. And anyways, the sketch is they're at a cafe. This guy, Robert Klein, comes in and he says, hey, it's 10 in the morning, I want breakfast. The guy says, no breakfast, just burger, right? Just cheeseburger. He's like, it's too early in the morning for cheeseburger. I want some eggs. He says, no eggs. It's like, nobody eats burgers at 10 in the morning. And this guy says, yeah, he eats a burger. He eats a burger, cheeseburger, 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 cheeseburger. And he's replaying the log. And his cousin over here says, okay, cheeseburger, 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 and he starts putting cheeseburgers on the grill, right? He's replaying the event log, and the notifier doesn't know how to differentiate from a replay event, re-notification. So this guy says, okay, fine, I'll have a cheeseburger. He says, okay, cheeseburger. He says, no more cheeseburger, we're all out. How about some eggs? Okay. But that's exactly the scenario that this causes, right? So watch out for this. So how do you fix this actually? And I want to use this real world analogy. What piece of technology fixes this? What do they need?
Well, you just differentiate between when you're replaying and when the event actually happens.
Yes, that's right. What if it were a push notification? I'm shoving this down the throat. Cheeseburger, cheeseburger, cheeseburger.
You accept it? Acknowledge that?
Well, okay, so this guy knows his application. The whole point of when you say, huh? Yes, that's right. What they need is a circular buffer, right? A waiter wheel. Do you guys have these things?
No.
The order ticket goes on and the cook takes it off the other side. This is a circular buffer. No, totally. Who didn't go put themselves in college by working in a restaurant? Anyway. Waiters? Well, how do you do it here?
Like a spike.
Oh, yeah, like, well, that's a pop and push and pop
Yeah.
stack. Okay, this is a circular buffer, ladies and gentlemen. The way that it works is I put the new order, it's a message queue, right? It's a now, who takes the message off?
Chef.
The subscriber, because he knows the state, right? So if we're going to talk about integration with other buzz technologies, when we're using external updates to a system that may not have the same understanding of the data as the data system, we push that on to a subscriber-driven event queue like Kafka or something. That's how you solve this particular problem. Okay, so the next part of this. This is the mechanics of event sourcing in IoT, but like I said, there's a lot of really useful data. We can derive different views on the event log. We can interpret the log in many different ways. So part and parcel of all of this is gaining insight on the data, okay? So we need to interpret our data. We need to interpret the sensor stream or whatever it is that's coming in to understand both where our alerts should be, where our current state is, and maybe some other learnings, like when someone's heart rate goes up and their position in the world is changing rapidly, we know they're probably running, or who knows what's happening. So we need a system for processing this data. Okay, this map is written in 1788. It is a map of the Gulf Stream. What it is that mariners would find when they returned back to England, that they could beat out the naval vessels, their contemporary naval vessels, and reach back to England 2 weeks before. The merchants knew that there was something out there that they could ride this freeway of water, this highway of water that would escalate them back over eastbound to England. So they knew that there was something out there going on in the Atlantic Ocean, and somebody figured out how to make this map in 1788. And it was easy because they had satellites back then that they could just image the Atlantic Ocean and watch it on a thermograph seasonally and then compare the flow rates. How do you suppose they did this?
Bottles?
Yes, you guys are so smart. It's right, Greenwich is right down the street. That's the problem, I see. It's the Maritime Museum. The person who came up with the system put a self-addressed stamped envelope inside of a bottle and threw it into the ocean. And he let people that were coming in and out of his port, sounds more festive than it actually is. He said, like, whenever you see these bottles, pick them up out of the water, write down where you found them, where your coordinates are, the date and time, and if you'd like, also what the weather conditions are, and then send that back to me. Mail it back to me when you get back to your destination. From that piece of data, you could derive where the Gulf Stream was. It was an amazing feat. Who do you suppose did this? Smart guy. Who did this? This gentleman, Benjamin Franklin. A very famous inventor in America, statesman. It made him the toast of Paris. Like he was famous for having done this, and that's why we got all the money to finance an insurgency that brings us to where we are now in this. But because he had done this, he was very highly respected in France, and so we sent him over there to get money because we didn't want to pay rent anymore. You know, we wanted to go solo. So anyways, that's the impact of the bottle in history. We need a system today that allows us to go over this kind of data and gain our insights as well. And that's what we're going to be covering in the next section. We're going to take a break, but there's one last thing that I want to ask you, one last quiz question. Who is this person? Any ideas? Can you even guess what year this photograph was taken? This is 1918 if this photograph was taken. A very modern looking, very fashionable young lady. She was in fact Emmy Hennings, who is a Dada artist and a muse among the Dadaists of the time. She was the wife of Dada poet Hugo Ball, and she bears no relevance to anything I'm saying tonight. Let's take a break.
So